Okay, so I'll come in for this one and just kind of help you a little bit. So we have an x degree wedge of a circle whose radius is r, and we're going to roll that up into a cone. And the question is, what's the volume of that cone?
Well, that x degree angle is x out of 360 of the circle.
Okay.
So for the circumference of the circle, 2 pi times r, and then we have to multiply it by x over 360, because this is how much of the circle we're using.
Okay. So what does this represent? 2 pi r times x over 360.
It's this wedge here.
It's that
Arc.
What about that arc?
It's the length of that arc.
Okay, good. It's the length of that arc.
Or pi r x over 180.
And we can look at this using something I've been talking to you about a little bit lately, analyzing dimensions. Angles don't have a dimension, but even if they did, the dimension of the angle divided by this angle would have, the dimensions would cancel. So dimensions here just come from r, the radius, so this has a unit of length.
Yep.
Okay, and so this length is the length of that arc, and also the length of what?
It's also the length of the base of the cone, or the length of the circumference.
The length of the circumference of the base of the cone. Okay.
So this is r.
The slant height is r.
And pi r x over 180. I'll call this radius r2.
Okay.
So
that's fine. Yeah, I didn't plan very good.
Pi r x over 180 is 2 pi r2.
2 pi r2. Okay, sweet.
So divide by pi and divide by 2, rx over 360 is r2.
All right.
I should call that r1 then.
Yeah, I probably should have. Okay, so we just found a formula for the radius of the base. I'll write that over here. R2 is
R1
times x over 360. Okay. Now, do you remember what it was when x was 40 degrees and our first radius was 9?
I think it was 1.
Okay.
So, well, 9 times 40 over 360 is 360 over 360, which is 1.
Okay, great. So now that we have this radius down here, R2, what do we need to do next?
We need to find the height.
Okay, how are we going to do that?
Well,
Give you a little room to work here.
we can draw a right triangle. R2, R1. So, this is y.
Okay.
So we already used x. So r2 squared plus y squared is r1. Oops. R1 squared.
All right.
So y squared is r2 squared.
R2 squared, yeah.
Well, it's r1 squared minus r2 squared.
Okay, R1 squared minus R2 squared.
And so that means y is the square root of r1 squared minus r2 squared.
Okay.
And we could substitute r2 out for that.
Okay. What would happen when we do that?
So we would get r1 squared minus this squared.
Okay, does that simplify our life?
No.
Actually, it does a little bit. So you get y equals the square root of r1 squared minus r1 squared times x squared over 360 squared. So you got an r1 squared in both terms.
Squared. Yeah.
So this is r1, I'll take that r1 squared out of both terms, times the square root of...
Isn't it? Oh yeah, because you factor it
1
out.
minus x squared over 360 squared. Now, we can go back, and now we just have pi r2 squared times y, gives us the volume, right?
Yep.
But we can check and see if when x is 40 and this is 9, did we get, do you remember what the height was? It was, do you remember what the height was? The square root of something?
I think it was the square root of 80.
Square root of 80. So let's see if we get that, putting in 40 and 9. Well, r1 is 9, right?
Yep.
9 times the square root of 1 minus 40 squared over 360 squared.
Well, we get, that would be, I think that would be, because you can, 40 over 360 is 1/9, so that would be 1 over 81.
Alright, so what's 1 minus 1 over 81?
It's 80, 81, 80 firsts.
You get 9 times the square root of 80 over 81.
So the over 81 can come out.
As what?
It's 1/9.
Okay.
1 over 81 is 1/9. So,
The square root of 1
Yeah.
over 81 is 1.
so that cancels with that 9.
And what do we get?
The square root of 80.
Just like we got before.
Yep.
So, slightly more complicated to do it abstractly, but you work through it. Good work.